Now, let us continue our discussion of circuit elements by focusing on switches. Switches exist in a variety of ways to serve many different purposes. One of the most common purposes of switches is to control the flow of current through the circuit network. And the most simple and common switch is a single pole, single throw, abbreviated by SPST switch. And this is just like the switch in a room that controls a light. So initially, the switch may be open, i.e. the light is off. And this is represented as a angled line existing in between two terminals of your circuit network. Now, say you enter the room, turn on the light switch, which now closes the connection between the two nodes or terminals within our circuit network, and now current is able to flow through the remainder of the network, i.e. to the light within the room. We assume this change of state is instantaneous, i.e. there is no switching time associated with this mechanism. In reality, that's not necessarily true, but for our analyses, we will assume it's valid. Now, single pole, single throw switches are often configured in a break before make connection. That is, it prevents a momentary connection of the old and new signal paths. And this is represented as below. Say we have terminal A, terminal B, and terminal C, where we have a single pole, single throw switch that is going to exist in between these terminals. For time t is less than 0, our switch is connected between terminals A and B. As we flip the switch, as the end of our switch travels from B to C, there is no current flowing through the switch. That is, there is no connection between A and B or A and C. And then for time t is greater than or equal to 0, we now have a connection between terminals A and C such that current can flow through. We assume that this change of state is instantaneous such that there is no current flowing through A and B and A and C simultaneous. Rather, we would only have current flowing from A to B for time t is less than 0, and then from A to C for time t is greater than or equal to 0. Another common switch is a single pole double throw, or SPDT switch, that prevents our current from ever seeing a 0 value, and this is often referred to as a make before break switch. You can think about a single pole double throw as two single pole single throw switches acting between two terminals of interest. That is, this is represented below. Say we have terminal A, for which we have current flowing through, to terminal B, for time t is less than 0. Now we're going to designate a single pole double throw switch by putting little wipers on our terminals, such that as when we activate the switch at time t is equal to 0, i.e. our switch is in between the terminals associated with A and B, it's making a connection between A and B and A and C simultaneously, such that our current value is never 0. And then for time t is greater than or equal to 0, our current can flow between A and C, such that during the switching process, our current remains uninterrupted.